Alrighty, so we're all here for CSIS 42 Python. Alright, so there's two class sections, the 22 and the 23. Doesn't matter in which class section you are, you're welcome to attend the lectures. If you're in the face-to-face section, attendance is not required, so if you miss class, don't worry about it. You can still catch up online. So the way I'm going to measure the attendance is whether you logged into the class webpage, whether you turned in the assignments. So make sure you log in, okay? If you don't, I'll be able to see it. And if you haven't logged in at all for the first week, I think, I'm supposed to drop you. So make sure you log in. I have like a little welcome message in there. So I guess we'll go through that first. All right. So my name is Alex Stoikov. This is CSIS 42. There's 16 weeks in the semester, and due dates usually within the week. So if I assign something this week, turn it in by the end of this week, or let's say 7 days after it was assigned, right? So we assigned it on Thursday, turn it in by next Thursday. I am not going to enforce the deadlines unless I really have to. So basically, my usual policy is if you turn it in before the end of the semester, I will give you full credit for it, right? And yes, some people have taken advantage in the past and they turn in like everything at the end of the semester. So don't do that, okay? The reason is, well, other than not opening too much work for me at the end of the semester, but is because I offer a regrade. So if you turn in an assignment and you didn't do what you're supposed to do with it, let's say you didn't get 100%, you got 50, okay? I'll leave a little feedback. You can read the feedback, you can fix the assignment, resubmit it, and I give you full credit, okay? So the same thing applies for the midterm and the final exam, except for those I give you 50% back, okay? And you're also welcome to ask me before you turn them in, hey, does this look good to you? I say yes, then you turn it in. You don't have to worry about losing anything, okay? So it's basically set up for you to get an A, as long as you keep up with the assignments, which are not, overwhelmingly hard, and I give you lots of hints on them, especially in these videos that I'm going to record and the lecture notes and everything. So just keep up with the class, you'll get an A, easy, okay? Well, about as easy as it can get. Okay, treat it like a math class. Don't fall behind. If you fall behind, you're going to start getting more and more and more lost. Okay, if you don't have any programming experience, this is the perfect class for you. If you have programming experience, still good. You'll learn some new tricks with Python this time. So that's it. If you need help with anything, send me an email. The email is here in the welcome message. It's also on the main webpage. Please include CSIS 42 in the subject of your emails so that I know where you're asking this question about. So I have something like 260 students this semester, so just help me narrow it down. I'll get back to you within 24 hours on the weekday, 48 hours on the weekend, usually faster than that. Okay. One other thing that's in the welcome message of all these is we're using this new software called Canvas, which I'm not the biggest fan of, and it has a whole bunch of problems with it. One of them is your gradebook, right? So if I'm a student and I go into my grades, I'm going to see something like this, right? And notice how this little checkbox is on by default. So it will calculate grades based only on graded assignments. So let's say we have 70 assignments in the semester and you turn in 2 of them. And you got 100% on the grade on those. This thing's going to tell you have an A in the class by default. So you want to go in there and you want to turn this off if you want to see your true grade. Okay, it misled a couple of students in the summer. One student thought he was getting an A, ended up with a C. Another one thought he was getting an A, ended up getting an F. So don't do that to yourself. I actually had to fill in some grade change forms for the summer because I didn't want somebody to fail my class. All right. So, but you've been warned in advance, so I don't want to be filling up grade change forms anymore. because of this crappy software called Canvas. Okay, so Gradebook out of the way. I told you about it. Textbook. That's also in the syllabus or in the welcome message. There's some textbook that I have listed in the syllabus. Any of you got it? Why? You shouldn't have. That book is just there to be there because we need a syllabus. I mean, we need a book on the syllabus. I'm not going to use that book. Everything that you need is on the class webpage. I pretty much wrote the book for you, posted it on the class webpage, and you get to use it for free. Okay? So yeah, if you can return it, good. If you don't want to return it, it's still an extra little reference that you can use in there. Okay? But everything that you need, I will provide. You're not going to have to go and Google things or need a book to read to complete the assignments. I'll give you the examples and plenty to get you started. All right, so that's as far as the administrative stuff, right? I give you the times or the duration of this class. What's the last day to drop without a W, last day to drop with a W, right? We're meeting on Thursdays, the face-to-face section only. And again, even the face-to-face section, you're not required to be here, but if this is your first programming class, I highly recommend that you come to class, okay? Okay, so I'm going to jump to week 1, and there's a bunch of stuff in there to get you started, such as how to download and install Python and all that good stuff. Basically, what it is, you want to go in there and you want to Google Python. Right? If you just Google Python, you're going to, this top link, welcome to python.org. Right? There's even a download link in there. So if you click on the download link, that's going to take you to all the different versions of Python that you can download. I like version 3.4 or version 3, anything is good. I like that one better. Actually, I don't like the 3.5 as much, so anything that's like 3.47, I'm not sure if that's got the installation files. No, some of them won't have it. So let's see, 3.46. No, I think I'm gonna have to go to 3.44 or something. This one. There you go. Okay, so 3.44, and again, you can download whichever one you want, as long as it's any version 3, because that's the one we're gonna be using. And it has the different installation files. The other ones that I went through didn't have this. So if you have a Mac, get yourself the 64-bit most likely. If you have a Windows, get yourself this one right here, the 64 MSI installer. Okay? And if you're on Linux, figure it out. If you know how to use Linux, I'm sure you can figure out how to install Python version 3 on Linux. Okay, so this is how we install it on Windows and Mac. Okay, and I'm using a Mac right now, so you're gonna be watching Python on a Mac. Okay, but it pretty much runs the same as until we get to GUIs, graphical user interfaces, when we start doing buttons and stuff like that. Then it will look a little weirder on the Mac. And if you can figure out how to resize the buttons on the Mac, I would love to learn. But it just doesn't cooperate for me. Okay, and on Windows you can tell that okay, the buttons are this size, and you can try to do the same thing on the Mac, and you won't change the sizes, for me at least. Anyway, so downloading and installing Python, right? You download it and install the thing, and if you install version 3.4, it will always install itself in the C drive. So it's going to be C drive on Windows, C drive. And there's going to be like a Python 3.33 or 3.4, something like that folder. That's where the Python is installed. When it installs itself, then you'll be able to open it by just pressing, on the Mac, you press that little search thing, or do this, and you type IDLE. And you're going to have to do the same thing on Windows. You press the Windows key, type IDLE, idle. That's the integrated development environment for Python that we're going to be using. And looks something like this, right? So if you look at the top, you're going to see Python 3.44 shell. Python 3.44 is the version of Python that we're using, right? And it also shows up right here on top. Okay, this little window, the shell window, is where our programs are going to be running. Okay, a lot of the Python books, and the reason I don't have a Python book for this class or use it, is because most of them show you how to do like one-line commands and in the shell window. I don't want to do that. I want to show you how to write whole programs. We're going to have to save them a script somewhere. Most of the books don't show that, so that's why I'm not using one. Anyway, so this is where the programs are going to run, but not where we're going to write the programs. So if you are, if you're in Windows, there's going to be like a file menu. You press File, New File, and this little window shows up, or one of those little windows shows up. Okay, we'll say Untitled on top, and let's just write a little program. So print, in most programming languages, you're supposed to get things started by showing a little message, right? So let's do a little message, hello. And then I have to save my program. Right now it's saved as Untitled, right? I'm going to save the program as, I don't know, let's say this is my first program, p0.py. Okay? And I'm going to save it, I don't know, somewhere on the desktop for now. Okay? So now it's saved on the desktop, p0.py, colors changed. And I'm going to run my program now. Run. And the little hello message shows up here. Okay? So this is my program. When I run the program, the output, or whatever comes out of the program, shows up in the shell screen. So far, so good? Alright. So this is your first Python program. Now let's jump to the class thing. Okay? I'm just going to jump through this basic terminology and all that other good stuff. Okay, so there's a PowerPoint in there that I just opened, which is this basic terminology. So I have to give you a little bit of this so that, we develop a vocabulary for what is to come in the future. All right, so what's a computer? You know what a computer is? A machine that we can program with some instructions. The instructions are programs. That's what we're going to be writing. There's hardware and software. Hardware, all the physical components of the computer, which is what we're going to program with our software. Okay. There's input and output devices. Input devices provides input or information that goes into your program or in the computer. Mouse, keyboards, touchscreen, right? These are different kinds of input devices. Output devices are things like, the actual screen that shows you stuff, printer, that could also be an output device. Speakers could also be an output device. Okay? And you have your memory units and your processing unit, right? The processing unit is the brain of the computer, right? The Intel 7 or whatever. Memory units is where our running programs are going to be living while the program is running. So as soon as I run my program, it is placed in memory where it runs. Okay? Right? Input, output devices, memory and CPU. Okay, so memory and CPU constantly interact with each other. If you don't have enough memory, you will start treating your hard drive as memory, okay? And things are going to slow down a whole lot. There's two pieces of the processor. One is the ALU, the other one is the CU. The CU is this control unit which constantly transfers information back and forward between RAM and the processor's registries. And ALU is the arithmetic logic unit which does math, right? If you want to add two numbers, that's the ALU. If you want to compare two things to each other, see if they're equal or one is bigger than the other, that's built into the processor. It can do these kind of arithmetics. Okay, so that the arithmetic and the logic, that is part of the CPU, and that's how we're going to write the programs. We're going to take advantage of that. There's operating systems like Mac OS X, like Windows, like Linux, okay? And those are just a collection of programs that make the software and the hardware talk to each other or work together. Okay. Source program. Well, the source program that I just wrote is this, right? This little print here. That's my source program. Okay. And there's also an object program. You don't really get to see the objects in Python. Okay. If you are taking a C++ class, you can kind of see what happens. You basically get your code. This is your code, right? And then this code gets translated into an object file, and then the object file gets linked together into an executable. Okay, well, this is for a compiled language. C++ is a compiled language. Java and Python are interpreted languages. So there isn't a final executable file being created in Python. So if I write my Python program and I want to just run it, there's no way for me to just double click the thing and it just works magically by itself. It's because this is an interpreted language. You're going to need Python installed in order for you to run Python programs. Just like with Java, because Java is an interpreted language, you need to have Java installed on the computer so the Java virtual machine can run your Java programs. Same thing with Python, okay? And this is the reason why actually Python is installed. Python and Java are both installed usually on, if you have a Mac, if you have a Linux, right, those are Unix operating systems which require some Java programs to run and require some Python programs to run. So both Java and Python are installed on those. Okay? So anyway, now you know a little something. So high-level languages. Python is an example of a high-level language. You write one simple human-like instruction like print, and it knows to show some message. Okay, there's low-level languages like assembly, where you're going to have to write a whole page of code, and it's all going to be very tedious instructions like, oh, move this little thing from this place in memory to this place in the register, and now do a million of these, and then you're going to get some kind of a message. Okay, versus, so it is much longer and time-consuming to write in lower-level languages. It's harder to figure out what's wrong with them if something goes wrong with the programs. And that low-level language, the lowest level language is assembly language. Okay, so one place underneath the assembly language, or one step underneath it, is machine language. Okay, so if you're on a Windows program and you try to open up an executable file like the Windows calculator, you're going to see just a bunch of nonsense symbols if you try to open it as a text file. Those are the ones in the zeros. That's the closest that a text editor can try to translate those into your, some kind of a language. We don't write in machine code. We don't, normally do that kind of stuff. The best thing you can do is you can get a machine language and you can reverse engineer it into assembly language. And that is how they figure out the serial numbers of like Photoshop and stuff like that, where there were serial numbers for it. Okay, so there's a way for you to convert the machine language into assembly language and then play around with the assembly language. Fortunately for you, this class has nothing to do with assembly language. Okay, we're way on top of that. So what else? Some other terminology. All right, bug. Anything wrong with your code is a bug. Okay, and debugging means you going in there and fixing those errors. Okay, compiler is a program which translates your code into machine language or object code, and interpreter is a similar kind of a program that does the same thing. The difference between compiler and interpreter is compiler does the whole thing at once. So if you have a compiled program like C++, you compile the thing and you have a final executable file. That final executable file, you just double click it and it works. In Java and in Python, you have the code, you run it, and it's going to stop at this object code stage, right? And then from that point, you can't double click the object thing and make it run. No, you need, like I told you earlier, you need Python to run Python, and then Python is going to run the object code line by line. So compiled language, everything happens at once. interpreted language, it happens one line at a time. So we'll go line by line on your code and interpret them one by one. Interpreted languages are a little bit slower than compiled languages. So the operating system Linux is actually written largely in C, which is basically C++. And interpreted languages are more cross-platform compatible. So if I write it on one computer, I can get the code, give it to some other computer, and it will run fine because it runs on top of the Java virtual machine, and the Java virtual machine can run on just about anything, including your smartphones. If you have an Android, that stuff is in Java. Okay? So compile time errors. So like I said, bug is just anything that's wrong with your program, and then we can call, there's different types of errors. One is a compile time error. What is a compile time error? Well, let's say, for example, the syntax of the language, these are also called syntax errors. Right? So the syntax of the language is, okay, this is supposed to be print, and then there's supposed to be a parentheses, and then another parentheses, but what if I forget one of the parentheses? And I'm going to save my program, right? And then I'm going to run my program, and oops, you get a little dialog box, unexpected EOF while parsing, right? So the program stops before we can even get it to run, right? So it doesn't even run. That's an example of a compile time error or a syntax error. So just like any language has its own grammatic rules, like in the English language, we got to end it with start with a capital letter, the sentence, and then end with a period or whatever at the end. Similar thing with Python. It expects you to start things certain way, end things in certain way, spell things certain ways. So for example, it knows what print is, but if I just went in there and I did, okay, well, capital print, and I try to run this thing now, it doesn't know what capital print is. Name print's not defined. So it knows what little print is, but it doesn't know what the capital print is. Okay, so that brings me to the next thing, that this language is case sensitive. So it does matter whether you write lowercase or uppercase, right? If you've done like HTML or something like that, that thing is not case sensitive at all. Python is. Most programming languages are. So that is different kinds of errors and methodology for a problem. Basically, you start with some set of requirements, like I'm the customer, I want you to write me a database software that's going to produce these kind of results using this kind of an interface. Those are restrictions. That's what you have to follow. Okay? And based on that, you develop a product. Modularization means just breaking the big problem into smaller, easier to solve sub-problems. Like you're not going to figure out how to write the program for the car that drives itself all in one big piece. You're going to break it down into little pieces. Well, we're going to focus on what these sensors at the front are doing. How are they supposed to work? And then break the little sensor itself into smaller and smaller and smaller, easier to solve pieces until they become so easy to solve that it's almost trivial. So then you start putting the pieces back together. As you solve the individual problems, you start putting them back into the bigger puzzle, and that's the modularization, okay, or functional decomposition, or whatever they want to call it. Okay, and what's an algorithm? An algorithm is a finite step of instructions, right? People like to think of algorithms, oh, it's some mathematical equation. Not necessarily. A recipe for boiling an egg is an algorithm, right? You boil the water, you put the egg in it, you wait for like 10 minutes, and then you turn off the heat. Okay, that's a recipe. That's an algorithm for boiling an egg. So it's just the step-by-step instructions that you can follow to solve a problem. Okay, most of the times we people are not used to thinking in terms of algorithms. But when you have a really big problem, it helps you to break it down into pieces so that you know which step of this you're doing. Okay? The algorithm for most of your programs is going to be what goes into the program. What information are we going to type into the program? Then next one is, okay, what is the program going to do with that information? Like, what are we going to multiply these numbers that the user entered, or are we going to calculate something? How we're going to do this? And then this last one is how we're going to show that information. So input, processing, output. Most of your programs are going to be like that. Okay, with a few exceptions where you're going to have a program that doesn't even have any kind of input from the user. But most of the programs you're going to do, you're going to simulate the user, you're going to enter some information into your program, the program does something with it, shows you some results, and that's it. Right? Input, processing, output. Always think of it that way. Okay? And then I'll give you examples of all these good things. Input, output, instructions. That's a little bit more information that I want to tell you right now. Okay, good enough. So that's that one. And I have another one in there, which I think is pretty much the same thing. But let me just look at it real quick. Yeah, this is just basically the same thing, just a little more, some different examples. So this is, I was telling you about assembly language. This is the assembly program that you have to write to show like a little hello world message in the, with the computer. And this is a high level language. All right, so it's a lot shorter, it's a lot easier to understand. Here you have things like move, MOV, move, EDX, LEN. Well, what's EDX? What's ECX? They're registries in the processor, right? So you're literally telling it move this piece of information into somewhere in the processor, etc., etc., etc. You don't have to go through all this stuff with a higher level language. Okay, interpreter, compiler. Oh, this picture is kind of neat. So that's the one. Just one more time. So this is an example of what happens with a C++ program. Right? You have your C++ code just like you have your Python print, right? Then that thing gets compiled into an object code. Then the object code gets linked by linker into a final executable code. Okay? With a Python program, we still have a compiler. We still have a sort of an object code, but this is where it stops. Okay? We do not link this stuff into a final executable. We stop at this point, and then a virtual machine starts interpreting it, or interpreter starts interpreting this code and executing it line by line. Okay, so that's that. And the other stuff I already told you. All right. So, all right. So then I'm going to continue with the rest of it. Comments, output, variables, input. Okay. So first of all, comments. Very important thing for this class, because if you don't have all the comments that I want you to have, you're going to lose, I don't know, anywhere from 30 to 60% on the assignment, because it's very important. Okay, so comments that you need to have. First of all, what is a comment? Comment in Python is anything that starts with a pound. Okay, this is a comment. So if I run my program, I just added this to my program, right? I'm going to run my program, and it still shows the same thing. So comments do not affect your code. Okay, so comments are not considered part of your code, right? Comments are just explanation of your code. Explanation for who? For other people that are going to read your code. For yourself. If you open up your programs 3-4 months from now, would you know how and why you did the different things in there? No, I don't expect you to. And that's one thing that I'm not big on memorization things, right? I don't expect you to, you have to memorize this piece of information, and then I'm going to do a closed notes midterm, and then I'm going to do the same for the final. You know what's going to happen in 3 months after that? You're going to forget all of it. Right? I took 3 semesters of calculus, then 1 linear algebra, 1 differential equations. Guess how much of that I remember? Very little. And that's just natural. If you don't use it, you lose it. And I mean, I come from Bulgaria. I start forgetting my own freaking language. I'm not even kidding. All right? So if you don't practice it, you're going to start forgetting it. So that's why you're going to write comments in there that are going to explain how your code works. You're going to explain it to yourself. You're going to explain it to others too. Okay? So what kind of an explanation? Well, I don't know. This is print is how we show output. Right? What's output? Output is information that comes out of the program. Right? And notice what's the format? We have some kind of a text inside quotes, right? And it's how we show some kind of information. So anything in quotes, right, will be shown exactly as is, right? So anything in quotes, oops. Does that make sense? So if I go in there and type this as a capital H, and then I put an exclamation at the end, and I run the program, it's exactly how it's going to show. Okay? So the message that we're going to show is inside quotes. Maybe, for now. So, what else? Okay, so anything in quotes is a string. Okay, so this piece of this message here that I have in quotes, that's a string. What is a string? String is text. Okay, and that leads me to the different kinds of information. Okay, different types of information. All right, so what are the different types of information? Those are also known as data types. Okay, so what are the Python data types? And by the way, at the end of the class, I will post everything that you see me right here on the class webpage, including the video. All right, so I'm your designated note taker, not to worry. Okay, so I'm recording myself and I'm writing these notes for you too. Okay, you and the online class. So, different data types. Well, I already showed you one, text, right? So, we have text, which is a string, which is anything in quotes. Okay, we have numbers, and there's two kinds of numbers. We have whole numbers, which are called integers. Okay, and we have decimal numbers, which Python codes floats. Other languages have doubles, Python doesn't. Python don't. Okay, so text, numbers, I'll leave it at that for now, right? There's other types of information. There's like lists, there's dictionaries, right? But let's not worry about them yet. So text and numbers. Okay, so this is the kind of information that we can store into our programs. Okay, so how do we store this information? We store the information using variables. Okay, what are variables? Variables are words we make up. That's it. Okay, so for example, okay, and words that we make up which refer to some place in memory where information is stored. Okay, so just like you have your internet, like google.com is some IP address like 172 dot whatever. I'm not sure what the IP address of Google is, right? But it's much more difficult for you to remember some string of, I don't know how many, 3, 6, 12 digits than it is for you to remember google.com, right? Plus, the IP address of Google can change over time. You don't have to worry about that as long as you remember google.com. All that translation from the words to the IP address gets handled automatically. Well, that's the idea of variables. Instead of me saying, okay, there's going to be this memory location and there's like a million memory locations and I have to refer to it by its specific number, I'm going to use a word that is the same as using that number. Okay, so that's what a variable is. It's a word we make up to store some information into memory. Okay, so let's say, for example, I'm going to have a variable. So this is going to be name equals Alex S. Right? So this here, this is my variable name. Variable name is name. Okay, that's the name of my variable. The space that I add after it, not important, right? And this is content or information stored in the variable. Okay, so this is the piece of information that's inside of the variable. What is this? Well, it's some kind of a text or string. Okay, so this is a string. It's something inside quotes. All right, another one. Age. All right, let me move this up a little higher. So you have age. I'm going to put a little extra spaces so it lines up. And I don't know, age 19. Okay, so this is, what kind of information is this? This here is a whole number or integer. And let's do another one, weight, right? Weight is going to be a decimal number, so let's say we do 175.5, and then this is a decimal number, also known as float. Okay, so those are the three types of information and how we store them into variables. Okay, this the equal sign has its own term. We call this the assignment operator. Okay, any questions so far? Make sense? Basic stuff? All right. So there are some rules for the variable names. Okay, rules for variable names. Okay, first is I can't start. Well, first of all, let's run the program, make sure it works. Notice I'm writing a lot of comments, so I'm explaining. If I was writing my first program in any language, I would probably write a whole lot of more comments too. So my point is, document your code so you know exactly how every little piece of it works, so that you can go back to that program and explain how to yourself how these things work. Okay, just like I'm doing for you right now. Anyway, so rules for variable names. Check if this works first of all, and this is something that I emphasize a lot. Test your programs often. Okay, so don't write like 20 lines of code and then keep your fingers crossed and then run it and see if it works. You can do that, but when you get comfortable with programming, when you become good at it. Anyway, so my program works here, right? No error messages. Okay, we're good. So far. So do this often so that you make sure that there's no error messages. Question?
What are you pressing to learn?
Oh, to do this on the Mac, I do Fn function 5, and on Windows you just press F5. Yeah, and then if you forget it, it's right here. So yeah, run is F5. Yeah. So the point is, this thing worked so far. Now let me try to rules for variable names. First rule is no number in the beginning. Okay? Or can't start with a number. Let's do that. Can't start with a number. So if I go in there, I put a number right here. One name. I try to run the program. Oops. Invalid syntax. It doesn't even tell you what's invalid about it. But now you know. Can't start with a number. Okay? You can get that number and put it here. You can also put it at the end. That will be no problem. Yeah, program runs, no syntax error. Okay. Let me resize this a little. Okay. So yeah, numbers are allowed anywhere except in the middle. Okay. 2, no spaces in variables, in variable names. So I cannot go in there and do this, space. If I try to do this, invalid syntax. It thinks that it's two separate things, so you can't do that. Okay, so no spaces in the variable names. Third one, no special characters, such as those, right? Only the underscore is allowed. So I cannot go in there and put any of these other ones, or I'm going to get another syntax error. Okay? But I can put an underscore. Okay, so an underscore is allowed in variable names, no problem. Okay? So that's third one. I'm not sure what else was there. Let me double check. So variables, and there's some explanation in there. Did I put rules for the variable names? It would be nice if I put it. No, I didn't. I usually put the stuff in the lectures. Let me look at the lectures real quick. And these are some of the older lectures, right? No reserved words. Okay, yeah. Okay. So the other one is don't use reserved words. Okay, it's not really can't, because Python will allow you to do this. So do not use reserved words. Okay, and why is that? Let's say, for example, up here I have print in purple. Okay, so this is a reserved word, and my program works, by the way. So let me just test it. Right, no problem, still working. So I'm going to go in there and I'm going to use my reserve. I'm going to use print as a variable. I'm going to say, all right, well, print is now equal to 1. Python will allow this. Okay, and other languages like Java and C++ and C will realize that, wait, print is a reserved word, and it will give you a syntax error for doing this. Python will let you do this. Okay, so if I run it now it's telling me int object is not callable. Why is that? Because I went in there and I changed what the meaning of print is. So normally print is supposed to show a message, but now I made print equal to 1, and now I can no longer use it in its original form. Okay, so that's why don't use reserved words for your variable names. Right? Don't use reserved words such as print, input, int, float as variables, variable names. Okay? And last but not least, fifth one is, if you're going to have a variable name, make sure it's a meaningful variable name. Don't call this, instead of name, don't call it string1. Instead of this age, don't call it num1, and then maybe my weight's going to be num2. Like, which one is what? What are these variables supposed to contain? What kind of information? Well, if I have meaningful variable names, it makes a lot more sense when you're reading your code. Okay, so use meaningful variable names. Okay. All right, so now we know the rules for variable names. If you break these rules, you're going to be unhappy. And let's see what we use these for. So we already saw that we use the variables for storing information into our programs. And now what I'm going to do is I'm going to get the user to enter information into these things. Okay, so I'm going to go in there, and so this was output. All right, and we had variables in here, and now we're going to do some input. So this is input, or information goes into the program. All right, do it in the program. So how do I do this? Well, there's three types of input. There is a default or string input, and that is basically saying, all right, name is equal to input, please enter a new name. Okay, how is this going to work? Well, let me show you the content of this. So print name, let's do it with double quotes, not to freak you out. Name equals name. Okay, so what I'm doing here is I'm showing output a variable. Okay, so this is going to be my, this here is just basically a label, and this one here is the content of the variable name, right? So name is originally this. When the program runs, it's going to show this little message. It's going to tell me, please enter a new name. I'm going to enter something on the keyboard. I'm going to press the enter key. As soon as I do that, the information that was stored inside name will be overwritten to whatever I just typed in, and then I'm going to show that. It goes like this. All right. So now it's saying, please enter a new name. What is this? So it's right here. Okay. Normally before, notice how it kind of ended. Right? This program hasn't ended yet, so it's waiting for me to type something. Right? That's my new name, and that's the content that now is stored in name. Okay? That's a variable. Changes its values. Okay? So that's the default input. So input is for a string. Okay? Whenever you say input, that's a string. Okay? This little message here that I have in quotes, this piece is called a prompt, okay, which is basically tell the user what to enter. Okay, if I don't have a, make sure you have a good prompt. Just like you're supposed to have meaningful variable names, you're supposed to have meaningful prompts. I could erase my prompt or make it something nonsense like this. Like, do you know what the program is telling you to do? Do you know what should be done? No. Okay, and you can even erase the prompt. You can go in there and erase the prompt completely. Like this. Run this thing. And now just the program is just waiting there. I don't know which one is more meaningless, right? The question marks are this. So the moral of the story is make sure that you tell the user what to do. So you need to have a good prompt. Okay, please enter a new name. So that's my prompt, which tells the user what to do. All right, so this is the default string input. Now what I'm going to do is I'm going to do integer. So integer input. Okay, so I had an integer variable up here called age. I'm going to say, all right, age is equal to int input. And this time what I'm going to do is, I'll just leave it like that. Actually, I'll do it this way. So I'm going to say, no, I'll leave it simple for now. So please enter a new age. Okay. And then I'm going to do the same business as before. Print age equals age. Okay. So a good practice is for you to have some kind of an input, and then right after that show yourself what the input was. Okay, because sometimes you think that it's going into the variable and it's stored in the variable, but it's better for you to actually see that it's really the information that you entered into the program is stored into the variable that you thought it will be saved in. Okay, most of the times if something's wrong with your program, like the program's not working, it's because the content that's stored in your variables, or one of the variables, is not what you think it is, right? And if you show yourself the content of the variable like this, right? Show myself the content that was entered into variable h. If I do this, then I see with my own eyes that the thing's working. Okay? So, please enter a name, whatever. Please enter a new age, whatever. Okay? So now I entered a new age, right? At this point, it stops. Right? So it stopped at, let me resize this thing a little bit. Alright, so please enter a new age. That's this right here. I entered the value 133. I hit the enter key, and then that information goes into the variable age, and then I show it here. Okay, so that's an integer input, and let's try to mess with the integer input. So first of all, for my name, you could see that I could enter whatever it is I want. I went in there and entered semicolons, all kinds of nonsense. So let's go back real quick. What I'm going to do is I'm going to turn off this piece of code for now by making it a comment. And I'm going to go and try to run the program, and I'm going to enter different things into for a name, right? So name was, okay, Alex S. All right, that works. One more time. I'm going to give it a number, 3. So that's an integer. That works. Go back, run it again. Now I'll give it a float, 3.14. That also works. So the input, okay, input can be string, int, integer, or let's call it int, or float. Okay, so I just demonstrated to you and I showed you that we can do a string, we can do an integer, we can do a float. Okay, now let's try this one. I'm going to go and try this one. Alright, run it. So the name of it already, we know that could be whatever I want. Now age. So obviously it's supposed to be an integer, so an integer like 3 should work. And it does. Now I'm going to run it one more time. Alright, so name could be whatever. Now age, let me try to give it a string. Oops, can't. Okay, value error, invalid literal for int with base blah blah blah. So it's basically telling you, I'm expecting an integer, right, or a decimal integer even. That's what it's telling you with base 10, and you're giving me this nonsense. Okay, so that's the translation for this error message. Okay, so you cannot enter an integer, right, or you cannot enter a string. So input cannot be string. Right? We already saw that it could be an integer. Now let's try to run the program and try to enter a float. Right? Name could be whatever I want, right? Because it's a string. Then the age, I'm going to try 3.14. And oops, again, invalid literal for int with base 10 when you're giving me this information. Okay, so the next one is basically you cannot be entering a string or a float. Okay, so input, so int input can only be integer. Yes? All right, and then the last one is basically the same thing. I'm just going to copy this whole thing, paste it, and the next one now is the weight. Alright, so this one now is a float input. So this is float. This here is going to be a float. This is float, weight, a new weight. Okay, and what I'm going to do is just for a little bit, I'm going to turn off this earlier code, make it a comment, because I don't want to be asking myself to enter things over and over the same stuff. So I'm just going to focus on the last one. All right, please enter new weight. Okay, so this is expecting to have a float, so let's start with the float first, 3.14. That works. Okay, let's try it again. This time I'm going to run it, and I'm going to try to enter an integer. Still works. Okay, so the input can be, so it can be an integer, right? It can be a float. And let's try a string. String. No, could not convert string to a float. That one's actually even a nicer message. Tells you what the problem is. Okay? So you cannot be string. So if you have a float input, you can enter integer, you can enter a float. If you have int input, you can only enter an integer, right? And if you have just input, then you can enter whatever you want. String, integer, float. Float is a decimal number. So anything that's got a dot after it, right? And notice what it did when I entered a 3. It shows it like this. So if you have a number, even if it's a whole number, but it has a 0.0 after it, Python considers it as a float. Okay? Okay, so a whole number, no decimal. Okay? Okay, so you know what a variable is, you know what comments are, you know what output is. What else? Well, let's do this. So now we have this information. Let me show you different ways to show these variables. So far I've used this little print, comma, and then the variable name, right? Does that make sense? So you show some label, then you show the content that's stored in the variable. Okay, so that's good. Now let me do it. I'm going to do it right here before I did the input, right? So this one here, I'm going to call it formatting your output. Okay, and what I'm going to do is I'm going to make this a little bit bigger of a number. Now let's do this. Okay, so the first thing I'm going to do is different ways to do the print. All right, basically. So first one is just the basic print. Print name equals name, age equals age, and weight equals weight. So I'm showing you how to show all the variables on the same line. If I run it, it shows it like this. Okay, and then after that it's asking me about the input. For me to stop the program, I just press Control-C, and that kills it. Okay, so Control-C to stop the programs from running, because I don't want to go and enter name and age and weight and all that stuff every time. Okay, so that's one way. Another way to do this, and I'm going to do the same thing basically, is you don't have to use double quotes, right? You can use single quotes. So single quotes, single quotes, single quotes here. Right? Python can't tell the difference between double quotes and single quotes. It's the same exact thing for it. Okay, other languages think that single quotes signifies a character. Python doesn't care. Double quotes, single quotes, still a string. Okay, so I guess I can go and correct this thing that anything in quotes be shown, so quotes, right, or single quotes All right. So the same thing, same rule applies to both of them. Okay? Got it? So anything in double quotes or single quotes, same thing, it's a string. So that's what this is. Okay, now there's another way to do this. And let's say, for example, I don't like to see 3 decimals. I want to round this thing to, 1 decimal. Okay? So I'm going to go in there and I'm going to copy this thing because I don't like to type so much. And I'm going to do this. I'm going to do it a couple ways. So this way is I'm going to say %s. This is going to be %. This is going to be %i for an integer. This is going to be a %. Then I'm going to have a %f for float. And this is going to be a %. Okay, and a little comment in there. %s is string. %i is integer. And %f is float. Just so you know what these are. Right? So what I'm telling it here is we're going to insert a string. What string are we going to insert? Well, whatever is stored into my variable name. Here I'm telling it we're going to insert an integer. Which integer are we going to insert? Well, whatever's stored into variable age. Here I'm going to insert a float. What float? Well, whatever's stored into variable weight. Okay, I go in there, I run this thing, keep my fingers crossed, and now it shows like this. Okay, so pretty much the same as the other one, except I still didn't get this thing rounded to what I want, right? Okay, so now next thing is I'm going to copy this thing, paste it in there. Instead of %f, I'm going to do 0.2f. Okay, and what is the 0.2f? %.2f is a float rounded to 2 decimal digits. Okay, I run it again, and now it's got 2 decimal digits. Okay.
Why previously it has 3 more zeros?
That's the default. If you do %f like this, right? This will show you 2, 4, 6 decimals by default, right? Normally you wouldn't do that %f. You would do something like this, right? That's the only time you would be using the %f, so that you can round it a little bit. So that's one way to do it. Another way to do this, right? And these are pretty important because, well, trust me, take my word for it, they are. Okay, so what I'm going to do is I'm going to combine. So far I've been using these commas. Now I'm going to get rid of the commas. What I'm going to do is this. I'm going to put parentheses around this last one. And I'm going to get this one. This is the first one. I'm going to get the second one. Put it there. Then I'm going to get rid of these here. Something like this, maybe 2 spaces. Okay, so hopefully this piece here underneath is going to work the same as, so these two are pretty much the same. All right, so these two are the same. Same. Okay. Keep your fingers crossed, run this thing. Spacing might be a little off or whatever. Yeah, I gotta move the space back a little. So let's go back, make it perfect. So age, get rid of that space. I think weight also. One more time. There you go, perfect now. So you can see that these last 2 lines are same. Okay, all I did was question. Percent where? In the I?
For example, yeah, for example, you use percent only for 2f and no percent for age or name. Will that work?
Because age is already age is an integer, so it does not have any decimals.
Yeah, no, I mean if you use, for example,
If I don't put a percent here at all,
yeah,
no, that won't work.
it won't work.
Yeah. So here I'm telling it, insert a string. Which string is it going to insert? The first thing here. Here I'm telling it insert an integer. Which one is it going to insert? So it basically knows, okay, first, second, third. It's going to be this first, second, third, right?
Actually, what I was saying is, for example, print parenthesis is name equals to name. Then, for example, age equals age, and then weight equal percent to F. You only use 1%
In this one here.
yeah.
Yes.
Does that work?
Yes.
That's
No.
combining both ways of writing.
You can't. Yeah, this is the syntax. There's one so if you're going to have if you're going to be inserting a single thing, so this is inside this string, we're going to insert one variable. Then you do it in this syntax, right? So if I had only one thing, if I can still put parentheses here, but I don't have to. Okay, but if I have multiple variables, so I have one string, and inside that string I'm going to insert multiple variables. One variable, two variables, three variables. Then the variables go inside parentheses. You put a percent outside of the parentheses, and then you list the variables in the order that they're supposed to show. Okay, that's just the syntax. Okay, so this one here, despite that you might be more comfortable with this, it might look a little easier. This one with the comma, wherever you see a comma, even this one here, is not always going to work. Okay, there's some, like for example, if we're trying to do similar thing with input, see how we can have a prompt that tells the user something. If you want to insert a variable inside of the prompt, you're going to have to do it this way. You can't use commas. Okay, so there's a reason why I'm showing you all these different ways to output. Okay, so that's one. And then one more way to output information is using the plus thing. All right, so I'm going to get this here, the original. I'm going to copy it. Okay, and then what I'm going to do is I'm going to add a little space here. This here I'm going to make it plus. I'm going to say str so that I can turn this into a string, even though it already is, kind of. Plus, add a little space here, here, plus, this is an str. Well, actually, let me show you what happens if I don't do this with the str business. So you can see this, and this is going to be plus str. Okay. So what I'm doing here is actually something called string concatenation. Before I tell you about string concatenation, before I do this, where can I put it? Where do I have the string? Okay, so I say I'll do string concatenation right here. String concatenation. So let's say you have first is Alex, second or last is, that's my last, right? And then I want to say first underscore last is equal to first plus last. This here is a string concatenation. What is string concatenation? Concatenation means combine the two strings into one string. Combine two or more strings into one bigger string using plus. Okay? So when I say plus this and the other one, what is it going to turn out to be? Well, print first underscore last equals first underscore last. Run it. And it's right here. Okay? So the first thing that I'm trying to show you is that when you have multiple strings together, right? That's string concatenation. Let's do more concatenation. Let's do this. I want to say first. Let's throw it in there. I'm going to put it right here. Let's put it this way. I'm going to have first is equal to still Alex. Last is going to be equal to the number 3. Okay, and I'm going to try to do the same thing as I did before. Okay, if I try to do this, Python will not allow it. Okay, can't convert int object to string implicitly. So I can do it explicitly. Okay, how am I going to do this? I'm just going to go in there. I'm going to say, all right, well, this is an int. So the error is can't convert int object to string. So I cannot. It doesn't know how to add a string and a number. Like it doesn't know what I want it to do. So what I'm going to say is, all right, hold on. Treat the second thing as a string too. Okay, so this piece here, this is known as casting. So cast the variable last into integer. And what is casting? Casting means temporarily force a variable to show or to change its data type. Right? I'm not changing last to be a string permanently. I'm just telling it, show yourself as a string right here. Why? So that when I do this, it works. Right? Alex3 works. Okay? And just to make sure that you understand, right? If I have first is equal to 3, or let's do it this way, 3, and last is equal to 4. I'm going to make it another 3. Okay, and I try to do the same thing again. Alright, first, last. I'm going to show you this thing. Alright, what is it going to show me here? It's going to show me 6. 333? Yeah. 3. Right? So if I run this thing, first last is 3. Right? This is string concatenation. And then this is not concatenation. Not string concatenation. Alright, so let's say I have this stuff here. Alright. So this one here shows us 33. What if I do this here now? I'm going to say int and last, like this. What am I doing now? Now I'm casting this first one, which is a string, to become an integer, and then I have another integer. So what am I going to get? Now it's 6. Okay? So there you go, 6. All right, so this is the 6. Just so you know, okay? So going back to the little thing that I had, where was it? Right here. Okay, the error that I'm getting here can't convert int object to str implicitly. That's the earlier message that error message that I saw. So what's wrong with my code here? What did I forget to do? Which one? Age, right? Age is originally, I don't know what. Age is an integer, right? But I'm trying to turn it into a string so that I can create one big string out of all that information. So I gotta go and say str here. Okay, str. Now run it. And it's right here at the bottom. It's basically when you have the plus, when you have a comma, the comma automatically inserts a space after itself. When you have a plus, you have to go in there and manually add the space. So I gotta put a space here. I have to put another space there. All right, and then it will look like the other one.
Alex,
What's up?
why at the top, when you use concatenation, it adds up to 6, but in the bottom it doesn't add up?
In here, why doesn't add up?
Yeah, why?
We're trying, because here we have just strings. This one here, the one with the 6, is not string concatenation, because what we did was we just got this first one and we forced it to be an integer, and then you have an integer plus another integer. So you have basically 3 plus 3, and then that's a 6.
Oh, so it does the math.
It does the math when you have two integers. Right? So two integers, so it does the math. Right? So two strings, so it concatenates. That's why. Good questions. Okay? So input, output, formatting your output. These are the basic ones. There's another one, a little fancier format that will let you insert commas. Let's say if you have a really big number and you want to have like a million separator or whatever, you can do that too. 1,000 separator, I mean. So all these different things are in here. Comments, output, variables, input, and I'm just about done. I want to show you how to submit assignments. Oh, and I'm not done with the comments, by the way. Okay, so on the very top of the web page right here, this week's students will learn about comments, and I showed you these kinds of comments. But then there's also on the bottom that it says multi-line comments, and let me click on this link here, comments. Maybe I have some information in there. All right. So if at any point you forget what you're supposed to comment, look at this web page or the comments page. Okay. So at the very least, the comments that I require for every one of your programming assignments is these comments on top, which is program name, number, or whatever. All the programming assignments, they're numbered. P1, P2, P3, P4. So save your program as p1.py and you're good. Okay, your name, the Python version, the when you started and when you finished this thing, and the description. Okay? Make sure the name matches your name. Okay? If you turn in the assignment with somebody else's name, you're not going to like the feedback that you're going to get from me. Okay? So at the top, these are the comments that I require. At the bottom, you're going to use multi-line comments to show me how the program ran. Right? So this is how the program ran. So you're going to go in there and you're going to copy this piece. You're going to paste it right in the middle of single quote, single quote, single quote, single quote, single quote, single quote. So in other words, if I go in there and I do this, alright, so this is my program. Let me finish running it. So name, Alex S, new age 3, new weight 3.14. Alright, this is my program. This is how it ran. So I'm going to grab this whole thing, copy it. I'm going to go all the way at the bottom of my code, single quote, single quote, single quote, paste all that stuff, single quote, single quote, single quote. Okay, so this is multi-line comment to show me how your program ran or tested. Okay, this is, I'm going to say 30% of grade. So if you don't show me how the program ran, I'm not going to run it for you. I'm not going to go in there and type 15 sets of numbers for you. I'm just going to give you minus 30 in the feedback so you can go and rerun it yourself. Okay, in the real world, it's very important for you to test your programs. You can't just, hope it works and give it to the customer and say bye, right? It has to work. So that's on the top, on the bottom, okay? So, and at the top, I need, at the very least, this stuff that's right here. All right, all this good stuff. So copy that, throw it in there. You can copy paste it if you want. So that's the program name. This is the P0, Python version, whatever, 3.44. And again, you should be using any version 3 is good. And what's today? 09 already? Nope, still 8. 08, 31, 17. If you started and finished it on the same date, good. Leave it as one date. Description, tell me what the program is supposed to do in as many details as you need. You can just go to the actual assignments and you can copy paste. So let's say, for example, you go to the assignments and I won't recommend going to the assignments like this. Go through the weeks that I have. But let's say we have, for example, this. Sum and product of two numbers. All right, so this is my program description. I can copy this whole thing here, copy it, and paste that thing in my code if I want to. You can use a multi-line comments to paste all that stuff in there. All right, like this. Why is that? So that you can look at your program and you know what it's supposed to be doing, right? Don't give me some brief description about, oh, well, it's just calculating the sum and the product. No, the whole thing. Okay, so this is copy paste description from the assignment. Okay, so these comments, the above comments document your code and are worth 30% of your grade. Okay? Question?
Each time you execute your code, you have a new session. Is that by default or version 3 or?
You mean every time I execute it, it does a new restart?
Yeah.
That's how it is. Yeah.
Okay, because I'm also version 2 and I can't do that. Okay.
Version 2, the print's not the same, the input's not the same. Yeah, many things are different. So no, don't use version 2. Yeah, version 3. Yeah, get 3. Okay, so that's the basic stuff. And then what I want to do is I want to go through the assignments that I have for this week real quick for the online students to pretty much, this is the first one. All right, so assignment 1 is, here's a picture of a program. Get it all typed up, including the comments, including the stuff in red, which explains to you what things are doing. All right, get it to run, and then copy paste your output at the bottom of your code, then submit it. So comments on top, comments on the bottom to show me how the program ran. That's the first one. So this is just to get you started. The second one is you're going to write a program that prints out CS in large block letters inside of a border of asterisks. So here's your little hint for this. If you totally get stuck on it, it's basically you just all the way at the bottom. All right, so this is your P2 hint. All right, you basically have this stuff, right? All I'm going to do is I'm going to go and I'm going to put a print quotes, and close that thing at the end. All right, and you do that for all the lines, and it will make the nice little pretty CS thing. All right, and you copy this at the end. All right, do it there, and these other ones, I'll let you do it. Do the rest yourself. All right, so if I run this program, and my name, my age, my weight. All right, so it shows you this. So you're supposed to show the whole message. All right, so that's the number 2. Just gave you the hint, pretty much gave you the answer. Number 3, I have an example of input, right? Similar to the output example, right? Copy everything that you see here. You can change the name to your name and the weight to your weight, including the comments. Type up the comments so that you know why things are working, how they're working. And once the program runs, copy this at the bottom, paste it at the bottom of your code as a multi-line comment, or you're going to lose points. Okay, so that's that. 3, 4. 4 is similar to 3, or this one is similar to the other one that we did, right? Except the difference is the program is going to ask the user, please enter a letter, and then it's going to make a big C using that letter. How are you going to do that? Well, I give you a hint underneath it, right? You basically have an X is equal to input, and you're going to replace these letters here with %S, and then you're going to have a % parentheses, and you're going to insert the variables. And I actually went and I did it for both the C and the S. You can only do it. You only have to do it for the C. You don't have to do the S. Okay? Does that make sense? Any questions? We're good? All right. And I think that's the last one. Let me double check for week 1. There's also a little quiz that goes with, no, there's 5 too. Okay, so there's a little quiz. It has to do with these like PowerPoints that I have posted here. It's all in there. If you get stuck on the quiz or whatever, you can retake the quiz after you have submitted it. I have set them up all so that you can, if you don't like your grade the first time you took it, take it again. Unlimited attempts, the highest ones count. The highest attempt counts. Last one, P5. Do I have a hint on this? Yeah, so I guess this is your program. Write a program which computes the sum and product of 2 numbers entered by the user. Right? So I guess I'll show you one example of the sum. Whoops, wrong one. Alright, so this is number P5 hint. P5 hint. Okay, so you have sum and product of 2 numbers. Num1 is equal to int input. Does it say they're integers? Doesn't say anything, so I'll treat them as integers. Alright, please enter number 1, and you can do the same thing for the number 2. Alright, num1, num2, find the sum. Sum is equal to, let's make it capital S, sum is equal to num1 plus num2, and then print the sum of num1 plus num2 equals sum. Alright, and that's your P5 hint. Let's test it, because I got to do what I told you. I got to test my stuff. Name, age, weight. Okay, num1 is 10, num2 is 20. 10 plus 20 is 30. I'm going to copy my code, because I got to show you how to submit too, right? Copy this, put it at the bottom in the multi-line comments. Paste this stuff there. Save this. Okay, it's on the desktop. So now I got to submit it. Submit assignment. Choose file. Go to the desktop. Get the P0. Open. Submit. And that's it. It shows submissions here. Just to warn you, because Canvas sucks, if you resubmit another assignment after this one, let's say there's some assignments that will tell you, okay, do a couple of these programs. If let's say you did the first program, you ran out of time, you did something else, and then you went and you submitted the second program, you're no longer be able to see the first submission that you submitted. Okay, so for some stupid reason, Canvas hides your old submissions from you. I've complained about it, nothing's being done, but just so you know, if you submit something, you're going to lose your old work. Okay, so submit everything at once and back up your work somewhere like Google Drive or whatever. Okay, I think I ran out of time, 4 minutes extra, but I had to show you everything, and this is it. So thanks for coming. Hope to see you next time. Question? What's up?
I was wondering, can you show me like a real programming that's done by Python? I want to see like what's the end result of Python.
Okay, well, Python is mostly like hacking language. If you need to analyze data, you process it through Python. So there's not a lot of like real world visible things.
So usually you create something and you use that thing, or you add that thing to
You analyze it. You analyze data with Python most of the time. Yeah, you analyze data. You look through a whole bunch of data and then pull information out of it. We're gonna do that. We're gonna do that. Yeah. Yeah. The lecture today will be posted on the class webpage. Yes. Yep.